Hi everyone, I'm Larry Ryan. How do you prepare for a multiplayer game launch?
You always have to remember, as good as the black box, white box testing we do can be, we're never able to play the game or interact with other players the way that the public does. So it's only ever an approximation of what's really going to happen in the real world. And I remember bringing down a first party on Crysis 3 and getting an emergency patch through in 2 hours for something where we introduced a bug and we were making calls at something like 10 times the rate we should have been to a key service, and we were going to bring down a first party, pinging to find out the best servers to be playing on. Something that should have been parallelized, was serial and implemented in a poor way, can take down third-party services quite trivially.
You can do all of this kind of preparation and load testing, and there's a lot of very mature learning at this point about how to do that kind of load testing. But I think the most valuable thing that I do to prepare is preparing the people on my team and at my studio for the unexpected, because there's a lot of things that you can really figure out when you're launching something that's single player or even minimal multiplayer. But as soon as you get to large scale multiplayer, your players are probably the most important and unpredictable thing that's going to happen. And no matter what things you thought you were going to load test, your players are going to find that one table in your database that your load testing didn't actually cover, and it's going to explode. And that also goes for our teams. Most of us are going to, regardless of what we try to do in our industry, there's going to be a lot of work leading up to a launch, and people are going to be working very hard. And it's incredibly important to make sure that your back-end team and your server team get sleep and spend time with their families before that happens. Because most of your studio is going to be working really hard right up into the launch, but your server team, their job really starts when the launch occurs.
One of the things that we did, and I know that other folks do it as well, is that we try our best to make sure that we can turn off everything at some granularity, or to tune it at some granularity. So if you're paging the database at some number, then put that number on a tunable so you can change it. Every WebSocket message handler that the backend has, each one of them can be turned off individually, and it's like there's no expectation that QA or we have to go through and test every configuration of those. It's your get out of jail free card. It's like, this thing is really bad right now, and if we just turn that off, that feature won't work, but it allows you to then keep the thing afloat while you work on an actual solution.
We use an internal EA system called Marketplace as the backend for our store in Apex. If we have trouble connecting to the store, it locks you out of purchasing, and it will lock out certain combinations of legends, but it won't stop the game from running. So try and design the service so it can degrade gracefully in case of problems. It's not always possible, but usually you can flip things around in the way you think about them. But kill switches is the big one. Just be prepared to turn features off wholesale.
Degrading gracefully is an interesting one, because I find that the mindset for the networking team can be different, the mindset of folks working on gameplay. So what one person might think, like, this is essential, you have to have your character customization before you enter. It's like, well, maybe you wait for 30 seconds, and if you don't get it, maybe the player would rather just play a game and then have to wait, then not get in at all, or whatever.
I'm not sure how many of you were playing World of Warcraft when it first launched, but our load testing assumed that people would create a character, and then they'd click that character and they'd go in and they'd play. And there was a lot of, testing of that particular path. But what we found out was that people created many, many characters right as they got the game to reserve all of their names. And then they spent time clicking between them to look at all of their different faces and stuff. And every time you clicked between a character, it would load their clothes from the database. And so we had hundreds of thousands of people clicking between their characters rapidly and loading clothes from the database. And it brought the whole database down, of course. And for the first, I think, maybe week of World of Warcraft, most characters loaded in their underwear, because we had to quickly switch off the ability to load clothes from the character select screen.
What is the one launch day challenge that you've encountered that made you want to tear your hair out?
discovering that one system wasn't scalable. When we launched the figure on PlayStation last year, we overlooked that the matchmaking service wasn't scalable actually. So we encountered issue where the whole process was no longer able to cope with the amount of matchmaking requests we were receiving. We had to recompile the server with more C++ optimization. We had to beef up the single machine that was providing the service. But yeah, that was a very nasty surprise left by the former team.
So at what point in the development lifecycle do you start making multiplayer technology choices?
I'd be very surprised if a game that was expecting to ship multiplayer didn't start thinking about it pretty early. And the idea of like, we need servers is hopefully pretty rare these days, but it was extraordinarily common back in the early GameSpy days that we would get calls from companies and say, okay, we're shipping in a couple months and we hear you have a multiplayer SDK. Can we license that and put it in our game? And we just have to say, what? No, like you can't just compile in a multiplayer library a couple of months before you ship and expect your game to work. And they're like, what do we have to do? And we ended up actually spinning up a consulting business. Whenever a developer would call us asking to license our SDK and they didn't have any multiplayer, we'd send engineers out to them to try to help them get multiplayer into their games with better or worse success, depending upon how much they'd thought about it. To think, we had many entirely single player games with no idea of separating client and server or any sort of game loop like distribution. And they'd say can we put multiplayer in? And be like, no, man, you got to rewrite. It's not going to work.
Yeah, I've definitely gone through that pain of working on single player local co-op game, and it's like, okay, we want to add online co-op, and it's just like, all right, this is going to be the next couple of years of my life now, because it's
always a heartbreaking thing to have to tell someone that like their the structure and architecture of their game is not going to work for multiplayer, and it's going to require a ton of work. But it definitely used to happen a lot. Yeah.
So our designers at the time would make their level, and at the time it was actually difficult because they would play it in single player and they would be like, oh yeah, everything works, and then you would say, hey, what about local co-op? And they're like, oh yeah, right, forgot about that. And they're like, okay, let me just test that. And then you have to be like, okay, now online co-op, and they're like, oh. And so yeah, definitely working on Knockout City, working on Viper, the engine that we wrote for that from the ground up. It was like day one was like, okay, there's no mistakes here, this is going to be online from the get-go, which is an awesome place to be in as a network programmer.
Agreed. It's got to be as early as possible. If I look at the relative amount of testing we needed to do for something like Jedi Fallen Order versus Apex when we launched, it's a drop in the ocean, the cost for a single player story-based campaign. The complexities when you've got 60 people all interacting with each other on server performance, suddenly 20 people all decide to congregate together and not shoot each other. 20 Bangalores all in one place let off their ultimates at the same time.
Oh boy, yeah.
We can't possibly test for every combination of every legend versus every other legend. It's exponential in terms of the testing. We do as much automated as we can, and we're getting better at doing the automated testing, but that doesn't allow us to have a smaller QA team. What that means is the QA team can actually look at quality, not at, can I get off the map? Can I create pathological circumstances where the servers can't cope? We can automate a lot of that. And that allows the QA team to say, is this new legend any good? Do I like the ultimates? Do I like their guns? Do I like what they're bringing to the game? And how do they interact with the other legends? So yeah, that's kind of the test your own game, dog food your own game as much as you can. If you're not enjoying playing it yourself, why would the public?
So how has your development lifecycle changed to meet the needs and challenges of the game as a service model? I know we've covered that sort of tangentially during our conversation, but is there any other points that you guys want to bring into this?
One of the things that I think that almost every company can do is make sure that your engineering teams start to understand the power of shared memory on your servers. How to basically use that and work with kind of your server providers. It's something that we're currently not doing at Psyonix. We haven't had to yet. We definitely had to do it on a lot of MMOs because you'd have multiple world simulation processes, and the map was so huge you couldn't load your map into every process, or you could, but you'd only be able to get a few processes on your physical machine. And so being able to use shared memory, which means, basically there's a lot of constraints about how your processors are going to access that memory and how they're going to kind of refer to it, is incredibly powerful. And I found that even today, a lot of development teams don't truly understand the intricacies of, for example, like how a particular Linux kernel is going to use shared memory. But understanding that stuff is like magic. Suddenly you can go from having like a few server processes to hundreds of server processes if your gating factor was memory footprint. And if you start binning together your game sizes and your maps, you can end up saying, okay, this particular machine is only going to run 2-on-2 matches on this particular map. And suddenly a whole lot of stuff can go into shared memory, and you can just get this gigantic explosion of your capacity. And again, I think, if you're going forward, in 2021, the more people who understand how to use shared memory, the more powerful our industry is going to get with massive multiplayer abilities.
Awesome.
It was a pleasure chatting with you guys. Thank you so much for your time. Really, really appreciated it.
It was great meeting everyone.
I was just going to say it was great chatting with everybody.